Okay, good morning everyone. We're going to try to wrap up our module on generics today. So the topic for today is wildcards. So that's going to be probably the most confusing part of generics. So hang in there, okay, pay really good attention. When we talk about wildcards, the correct terminology is wildcard instantiation of generic types, as opposed to concrete instantiation. So concrete instantiation is a terminology I've not been using a lot until now, okay? But every time you say, I want a list of integer, you specify the type parameter, integer, okay? So you have something concrete. Well, the notation we are going to explore in today's lecture is going to be a little bit more abstract than that. We are going to introduce wildcards, also known as jokers, characters that can be replaced by other values. So you're all familiar with this when you do at the command line something like ls or dir, depending on if you're on DOS or Unix, and you do something like star dot, exe. Well, that's a wildcard. Yeah, question?
Yeah, number is a concrete instantiation.
Say that again?
Number, N-U-M-B-E-R.
Yeah.
Is it a concrete instantiation?
Yes.
Because it has two integer and double.
So the question is, if I create a list or declare a list of number, is that actually a concrete type because number can be subclassed into integer or double? And the answer is yes. It's a concrete instantiation because you provided the name of a type, okay, the name of a class, okay? Like think about it this way: any class in Java can be subclassed, right? So that means that if we were not allowing number because it could be subclass, then nothing would be really concrete, okay? You're going to see that the wildcards are really much less concrete than a superclass, okay? Okay, one way to look at wildcard is to look at them as the quote-unquote interfaces of parameterized type, okay? You're going to see that they allow us to set rules. Again, with Java generics, most of the time, we are not studying a way to do something we could not do before. I repeated that a few times, okay? We are just studying a way to do something we could do before, but do it in a way that the compiler understands what we are up to. And therefore, the compiler can provide us with some safety. That's the whole point of generics, okay? At least in Java. So when I talk about concrete instantiation of generic type, to go back to your question, yes, I'm talking about something like list of integer. And that means that I'm characterizing a single concrete instantiation here, okay? There's no ambiguity, it's a list of integer, period. When I use wildcards, I use the syntaxes that you can see here in the first bullet item on the bottom of the slide. So for example, list of, and you read that unknown, the question mark. So list of unknown extends integer, list of unknown super integer. So be careful, because it's normal if you have some degree of confusion between what we're going to do today with wildcards and bounded type parameters, okay? Because they look really similar. We used to do things like list of t extend integer, right? So one of the first difference is that in this case, well, I'm not going to tell you that we use a question mark. I think that's pretty obvious. But besides the bloody obvious, in this case also we allow ourselves to use both the keyword extend and super, okay? So that is not allowed in bounded type parameters. Another thing is when we use this notation, we use the wildcard, right? So the wildcard can be replaced by anything. So a list of unknown extends integer represent a whole family of possible concrete instantiation, okay? Anything that can extend the class integer. Last thing that I'm going to point out, that's not on the slide, but I keep reading this unknown, okay? Like list of unknown extends integer. It's important. It's important because the fact that we read that question mark as unknown is going to make sense a little bit later on, because you are going to be surprised at the amount of constraints that using this kind of notation bring into your code, okay? When you say list unknown extends integer, it's not at all the same as saying list of t extends integer, okay? The fact that the question mark is unknown is going to tell the compiler, I really don't have a clue what to expect there. And that's going to make the compiler lock down a bunch of things that we can do otherwise with those types. Okay? So keep that in mind, and I'm going to get into detail, of course. So another thing that stems from that difference, between a concrete instantiation of generic type and a wildcard instantiation of generic type is that when you have a concrete instantiation of generic type, you can use it as an argument, a type argument, an effective type parameter. Okay? You can say I'm going to create an object of list of integer, of type list of integer. Okay? I'm going to pass this parameter to a method. You can use it, of course, for reference variable, and as I already mentioned, create object. So just remember that concrete type instantiation can be turned actually into objects. If you remember even just that one, the others are going to follow from that. Now, when we look at wildcard instantiation of generic types, that's different. We can use them everywhere we can define reference variable. So local variable, a parameter for a method, stuff like that, all of that is allowed. But there's not as much allowed than with concrete instantiation of generic types. More specifically, so I already mentioned everywhere you can use a reference variable, you can use them. So parameter, field, local variable, I don't think I forgot any. Actually, when I mean parameter here, I mean formal parameter. Okay, definition of a parameter when you define your method. And then you could do that also with return type. Everywhere it said not encourage, do not do that. I personally have never had the need for it, never tried it. So try to just steer away from it until people start saying that it's actually usable. Okay. But the things that are forbidden explicitly: generic method invocation, generic class instance creation, so you cannot create objects, okay, of wildcard types, super typing, even just defining something like public class pair of unknown, that's not going to work. Okay, you can do public class pair of t, that's a type parameter, but if you say public class pair of unknown, there's nothing you can do with that question mark. You cannot use it as a type in the definition of your class, okay? So that's really not going to fit there. Same thing if you say, I have a list of unknown named my variable, okay? And I assign to it a new array of unknown parentheses. I call the constructor. That's not going to work. You are trying to call a constructor, and you are saying the type argument for the constructor is unknown. You see how the word unknown helps remember where you can use it, where you cannot use it? You are telling, I want to construct a new array list, and it contains object of unknown type, to which the compiler reply, well, when you know when you want to put in that array list, give me a callback, okay? Otherwise, we are not going to be able to create objects. So let's summarize a bit the syntax, because now we are starting to have like a bunch of different things, okay, that we covered. So I'm going to try to introduce the wildcard, but as I do so, I'm going to kind of like summarize what we have seen before so as to integrate it with what you already know, okay? So we already discussed at length, the concrete instantiation of parameter types. The syntax is easy: list of number, list of integer, list of employee, whatever. We talked also about row types. And row types are going to connect to actually wildcard instantiation of generic types. You're going to see the parallel in a very few slides, okay? The syntax for row type is list, but we have said do not use them. Why not use them? Well, because one, they are deprecated, so they might not be in the next version of Java. Actually, they are still in Java 9, but let's talk about Java 10. And two, they are unsafe. The compiler cannot check anything, okay? So that's where we started. And now we are introducing wildcard instantiation of parameterized type, of generic type. We are going to have like 3 different syntax that are already introduced. Let's name them, okay? The first one, let's start by the bottom because this is the simplest. List of unknown. That's called unbounded wildcard instantiation of parameterized type, okay? So I might abbreviate that into unbounded wildcards, okay? Just to make it a little smoother there. But that means that that unknown can be literally anything. So think object. Object is a class in Java that you use when you don't do generics and you want to say I will accept a parameter of any class, right? So this is kind of like what we're talking about here. So if we're talking about this level of generality, what does it make you think of? It should make you think to row types. Because row types is where we used to do programming, generic programming without generic syntax, just by using the object class everywhere, okay? So we are going to go further into that link, but I just want to point out all the connection right now. And then we have two types of bounded wildcard instantiation of parameterized types. The upper bound is this one. Upper bound means you extend, okay? So I want a list of unknown data type, but it has to extend employee. So it could be manager, it could be secretary, it could be legal secretary. I don't know. That's a key with unknown, okay? I don't know what to expect, but at least it should be a subclass of employee or employee itself. So it's called upper bounded, it's called subtype bound, okay? Whichever you prefer, whichever you have to deal with, depending on what you read. And then the next one, the last one, the third one is list of unknown super employee, which is, as you can guess, the opposite of the previous one. We call that a lower bounded wildcard instantiation. We call that a super type bound, okay? So super employee means that this unknown type has to be a super class of employee or employee itself, okay? That's why they call it lower bound, by the way, just in case you didn't connect, okay? When you say it's everything above employee, let's say that our hierarchy goes like that, everything above employee, that's the lower bound you just gave me. Everything below employee, that's the upper bound you just gave me. That's a nice way to remember it, okay? So, after all of this about wildcards, it might be useful, to kind of ask ourselves what they can do for us. So we're going to expand on those 2 points. That's going to be that section of the lecture, So just to give you an overview, the first thing that wildcards are going to allow us to do that we could not do before is they're going to allow us to play with inheritance between parameterized type. So you remember the deal, right? I have a list of number, I have a list of integer. I would like for the list of integer to be a subtype of list of number. It's not. So that caused us a little bit of trouble, in the past. Well, wildcards are going to help us with that. And then the second thing they are going to do, they are going to strictly police, actually, how we use our argument. So if you write a method and you say, my method is going to take, for example, a list of unknown, that's potentially great because that means that your method is uber generic, okay? You cannot be more generic than that. You are going to work on list of anything. That's great. However, because you said it's a list of unknown, the compiler is going to be really careful about what you are trying to pass into that parameter, what you're trying to get out of the parameter. So when people talk about wildcards in generics, they often talk about producer-consumer. I have not used that analogy in my slides, but if you read, there's one mention of it in the textbook, and if you read other sources on generics, you're going to hear people talk about producer-consumer. What they refer to is what you do with your parameter. So you say, my method takes a list of unknown parameter x, okay? If you are trying to put data into x, like it's a list, for example, you put data into it, then x is a consumer. If you try to get data out of your parameter, so x is a list of whatever, you try to get data out, it's a producer of data, okay? So that's going to frame things so that you can read over things on generics, and kind of do the analogy with what we're talking about here. So the whole thing about, policing access to that parameter x would be for the compiler to detect when you can actually safely is the operative keyword here, when you can safely put something of a certain data type into your parameter, your list of something, or when you can safely extract it and assign it to a variable of a given data type. Okay? So it's really does insert into, remove from operations that are policed by the compiler. So at that level, a list of unknown is almost the same thing as actually row type. It gives you almost all the benefit, but it will automatically shut you down if you try to use this variant of row type in the wrong way. So I'm calling that list of unknown, a variant of row type, but it's completely locked down by the compiler. Okay. So now let's go back over those 2 points and let's go into more details. So we said something about we are going to enable inheritance between parameterized type. So this is a situation we had before, okay? A pair of manager is not a subclass of pair of employee, okay? Assuming that employee is a superclass of manager. Now with our wildcards, we have something a little bit more interesting. When we have a pair of manager, for example, we can say that it is a subtype of pair of unknown extends employee. So bottom line, and this is why we use wildcard instantiation as formal parameter. Where would you need to do something like that when you want polymorphism? When do you want polymorphism? Well, in your parameters, right, for your methods. So when you define a method, you may want to use a wildcard instantiation like unknown extends employee, just to allow every programmer to call your method and pass as this specific parameter something that is also a pair of manager. So there you go, you have polymorphism, okay? Before, we could only say I want a pair of employee as parameter to my method. And that prevented us from being able to pass something, a reference to pair of manager. Now we are capable to do that, okay? So the diagram at the bottom of the slide shows a kind of hierarchy, inheritance hierarchy that we are capable to build right now, that we are capable to access. So on the left, the unbounded list of unknown, okay, is a superclass for just about anything. So any list of something, okay? I should not say just about anything because, for example, I don't know, my lovely class is not actually a subclass of list of unknown. It's a superclass for list of number, list of integer, list of double, list of employee, and so on and so forth, okay? So you replace that wildcard character, that unknown, by a type. And on the right is actually the more interesting corollary of this. Now we are considering not only list of unknown, but we are considering list of unknown extends number, list of unknown super integer, okay? So here's the relation. On the left side, your list of unknown is a superclass to list of unknown extends number, which is itself a superclass of list of unknown extends integer, okay? Because integer is a subclass of number, and number is a subclass of anything, like this unknown question mark. So we have what we were talking about here in this example, okay? We have this kind of inheritance hierarchy. And the last one at the bottom of the slide is list of integer on the left. So list of integer, subclass of list of unknown extends integer, subclass of list of unknown extends number. That's normal, that makes sense. Let's look at the right side of this diagram now. List of unknown super integer is a subclass of list of unknown. So same kind of relation between unknown extend something and unknown super something, okay? But then this is how it works, and sometimes it's a little bit counterintuitive the first time you encounter it, okay? But list of unknown super number is a subclass of list of unknown super integer. Think about it, okay? That makes sense. It's just that we have never been playing, you know, with this kind of, how to say, super keyword before to accept more parameter to a method, right? So this is the total opposite logic of what we have been doing with bounded type parameter and what we are doing with the left side here of this right side diagram, okay? So list of number is also a subclass of list of super, unknown super number, sorry. And if you stop here, you have like two different hierarchy of inheritance. And they are kind of the opposite of one another, okay? One goes in one way, the other goes in the other way, okay? And then we have those little cross arrows here. And the cross arrow tell us that a list of integer, which is at the bottom left here, is also a superclass of a subclass, sorry, of a list of unknown super integer. So it connects that way, and it connects the other way around, where our list of number here at the bottom is also a subclass of list of unknown extends number, okay? When you review those slides, when you re-listen to the lecture or read the reading assignment and stuff like that, keep this diagram handy, okay? Again, nothing is intuitive until you do it, you read it, you study it, you ask questions about it, okay? This is going to be your guide during that phase. Now, we have a nice technique, we have a new technique, we have a new feature, so let's try to break it, okay? It's actually a very good way to learn about something. So we are going to try to abuse this feature. So we define a variable, a reference variable named manager buddies. And this reference variable is meant to hold references to object of class pair of manager. Concrete type instantiation, okay, no problem there. So now we create a new object. This new object is created with a diamond operator. So we want to create a new pair of manager. Okay, the diamond operator is going to allow us to do inference like this. And we pass two other reference which we assume are two manager types of object, a CEO and a CFO. Okay, so now we have a new object pair of managers that contains two reference to manager objects. Everything is fine. Now we try to break things. So we define a reference variable. So we can use wildcards when we define reference variable. We say it's a pair of unknown extends employee. So some of you are going to probably think at this level, why do we care about defining a wildcard instantiation reference variable? Okay, well, we are using a reference variable declaration as a local variable just as an example. Okay, but you can use that for a field, local variable, and more importantly, as a parameter of a method, where it would actually have synergy with polymorphism. Okay, so it's just a simple example here to show how references interplay with wildcards and concrete type, but it has more concrete application when you use it as parameter of a method. So this variable, this new reference variable is called wildcard buddies. So we are going to try to mess around with that concept of pair of managers, and we're going to try to insert something else than managers there, okay? So we assign right now manager buddies to it. That's allowed. Okay, that's the point of wildcards. If wildcard buddies was actually a parameter to a method, by using unknown extends employee, I would allow people to pass to my method pair of manager. That's the whole point. Okay? So this one is not actually our problem. This one is. When we try to do, let's assume that we have a method set first and another method probably set second. Okay? Set first allows you to change the first element of the pair, set second the second element of the pair. Okay? So it's just a setter. So we are trying to use the set first method from the class pair of T, and we call it through the wildcard buddies reference variable, and we pass something that is a reference to an employee, a regular employee, and we're trying to put that into a pair of manager. Okay, so here's what's going to happen: compile time error. But the compile time error, that's what's important. Besides the detail, what's really important is to really understand why wildcards are interesting for us. The compilation time error happens because of the way we define our wildcard data type. Okay, our pair of anything unknown extends employee allows us to pass parameter or to assign references to that variable wildcard buddies that are actually subtype of unknown extends employee. This is okay. But then when you use the method of the object, automatically the Java compiler is going to actually check that you are using it correctly. In this case, I am not using it correctly. So I open the door to receive references in wildcard buddies, whether it's a local variable, a field, a parameter. I open the door to receive references that are subtype of unknown extend employee, but I make sure I close the door to any illicit usage. That's the benefit of wildcard instantiation. And it's the same kind of benefit that we have got all along with generics, right? They allow us to write generic code, but then they provide type safety. This is how type safety looks with wildcard instantiation. So let's go back to our table. This table is going to keep getting bigger. Yes, question?
So in the previous slide, in the project, I faced a similar issue. So I have an array list of population, and I'm adding instances of my candidate solution in that array list.
Okay.
So I made my array.
Hold on. So just to make sure I understand, you say you have an array list population in your project.
In my project.
Okay. And you are adding instance of candidate solution. So you should have actually in your class population, instead of an array list of population, you should have a class population inside of which you have an array list of candidate solution, and then you add your candidate solution to that list.
Yeah. So yeah, that's exactly how.
Okay. All right. So.
While using that, so it's an array list. So while adding instances to an array list, you use the .add method, and you add the binary fixed vector instance to the array list of candidate solutions. But the .add method is it gives a compile time error even if I make it an unknown type generator.
Well, okay, so your add method is giving you a compilation time error when you try to add candidate solution to your list. No, it should not give you a compilation error, and the solution is not to make it actually a wildcard instantiation. So the best I can tell you is bring your code during office hour. Let's take a look, okay? Because I'm pretty sure there's probably some detail missing here that are responsible for the bug, okay? So we'll take a look at that, but you should not need to use wildcards for that.
The only reason I was using wildcards is because I was using reflection to get the name from the config file and probably trying to create a new instance using the constructor.
Okay.
Adding it so that it can be autonomous, so only the config can be changed.
So okay, what's interesting is that you said the only reason I was using wildcard is because I was using reflection to try to build things. Okay, so I really need to take a look at your code because it looks like it's getting super complicated at a point in the code where we should really be able to create, instances of candidate solution and just shove them in. So there has to be something else that is wrong there, because you should not need reflection there. And even worse, combining wildcards and reflection is going to be a nightmare. So I'm pretty sure that I'm not seeing something in your code here that I'm going to see when I actually take a look at the whole code. Okay.
And my second question was, can you have an unknown type of interfaces?
Can you have a what type of interface? Sorry.
Unknown extends interface. So right now we've talked about classes and.
Oh yeah. Yeah. The same way, so the question is, can we have a pair of unknown extends, and the name of an interface? The answer is yes. The same way that you can, when you use, when you use any sort of parameterized generic type, you can have T extends, for example, comparable of T. Okay, that's an example that we have been using in the slide, and comparable of T is an interface. So yes, you can absolutely do that here as well with wildcards. As a matter of fact, I'm not going to, the worst we are going to see in the lecture are things like, for example, a pair of unknown extends comparable of, something, comparable of T. But you can go really far deep the rabbit hole with wildcards. You can have things that are completely insane to try to decipher, like for example a pair of unknown extend comparable of T, extend, and again and again and again, and so you are nesting, like things like that, and it's really, really atrocious to read. I've never seen personally example where you go past, having one nested into another. Two levels of pretty much generics, parameterized type is a must I've seen. But theoretically, you can have as many as you want, okay? The problem becomes, what does this represent? Like if one parameter of one of my method is written, with 3 lines with nested generics, then yeah, the problem is really what does it represent? And even more importantly, why can't I write it more simply, okay? So you should never have to deal with that, at least, in this course and probably in your career, I'm guessing. So back to this table, and as said, this table is going to keep getting bigger, so I'm going to start removing some rows and columns that are like basic stuff after a while, okay? But we're going to keep going back to this table and add as we study more things, okay? So the 2 columns that I added here to the right, they are there to represent, the second aspect of generic, policing access to method. Okay, so you have a wildcard instantiation generic type, and we saw that the compiler is going to check things when you try to actually add information to your parameter or retrieve information from your parameter. So I was taking the example of a list of unknown parameter to a method named x. okay? And I told you, well, X can be a producer or consumer. So we are going to look at it from a different aspect, but it's really the same thing, it's analog. We are going to look at it from the concept of getter and setter. So let's say that this X instance that's passed as parameter to my method has a bunch of getter and setter method. Okay, so what the compiler does is police usage of getters type of method and setter types of method. And we are going to start with what we know already, okay? When I have a list of number, concrete instantiation of parameterized type, okay? When I get something out of a parameter that is a list of number, I know exactly what I'm going to get, a number. When I add something to my list of number, the compiler forces me to always add a number. So that's the basic example of generic that we started with. Then we talked about row types, and pretty much the problems that we encountered with row type, we can summarize it like this, okay? When I try to get something out of a parameter from for a method that is of a row type, let's say list, okay? The only thing I'm getting is an object reference. I cannot get anything else. That's generics before generics, okay? Now, I can cast it. I can cast that object reference into an integer, a double, an employee, whatever I know, was in my list, but I have to do it by hand. So I lose type safety and compiler checks. When I want to set, same logic, okay? The setter of a parameter that is of row type list take an object reference. That's all it can manipulate because it's that generic. All right, so you can pass anything, but you have to be careful. You have to police yourself. If I insert into my list an integer reference, then next line I should not try to insert a double reference or an employee reference. Even though the compiler is going to let me do it, I have to prevent myself from doing it. Well, now what we are going to do in the next, I think, 3 or 4 slides, we are going to fill the blank for what happens here and here. Okay, and this is actually the hard part. We are going to specify what happened for the 3 different types of wildcard instantiation of parameterized type when we try to get something out of such a parameter or put something inside of such a parameter. To answer this question, this 6th question, we are going to use a variant again of the box class. All right, so box of t, let's go over it really fast. Box of t, concrete data type, generic type. By the way, you cannot use wildcards here. You cannot say I'm going to define a box of unknown. Okay, that doesn't make any sense. Why? Because t, the only purpose of t, the only reason for t to exist is that we can use it in the class. Okay, so I can say, all right, you are going to specify a parameter type, let's call it t, when you build an object. So I'm going to make sure that my private field lowercase t is of that same data type. But if I use a joker, which means unknown, well, then I'm going to declare private (t), private field t of type unknown. That's not going to compile. Okay? So just a side remark. So we have a private field lowercase t of data type, the type parameter t. We have a constructor, does what you would expect. We have what else? A put and take method. Well, we could have called them like set and get. That would not make any difference. So these are like respectively accessor and mutator, okay? Getters and setters. And then we have, just for the sake of example, we have a method contains that takes a parameter of type uppercase t. And all it does is test, if the parameter is the same thing as the field inside the box. And by the way, we use equal, so it's going to be a test that is very, very generic. We just test the references. And then we have a public string to string method. Does what you would expect from toString. It returns a text representation of what's in the box. So it just writes box, and between a pair of square brackets, it asks the field itself to display its information with toString. Okay? So nothing really fancy here. It's 99% similar to the box example we've had in the past. So what we are going to do with this box now, so we have one generic type, box of t. And now we are going to use it with wildcard instantiation. All right? So remember, we define local variable, like in this example, in my main, I have a local variable box, okay? So we define local variable, but this could be field, this could be, even more interestingly, parameter to methods, okay? So here come my lowercase box, my variable box. The data type of box is box of unknown. So I can define references, right, with wildcard. That's we've been clear from the get-go. Now I create an object. I cannot create an object with a reference instantiation type parameter. So I have to be concrete here. Okay? I want a box of string. And I pass to my constructor, well, a string. So that this is a string I want inside my box. So the part on the right side of the assignment, really nothing new there. The left side is just to open more possibilities. So I could assign to my box variable, you know, a new box of string. I could assign a new box of integer, a new box of employee. That's the point, okay? The box local variable would accept all of those. But then, when we start using the method inside the box object, this is where this part here of the code, the box of unknown declaration, is going to define the rules. Define what is acceptable, what is not acceptable, and all of that is going to be enforced by the compiler. Let's take the first example. In our first example, we use this reference variable box to call the put method that we previously defined, okay? So it's a setter, and we pass a string. And that's interesting because we have a box of string object, but this is not allowed. The compiler is not going to allow us to do that. And this is where it's becoming a little less, you know, intuitive than you probably would like, and even I would like. The idea behind this is, when you said, I have a box of unknown, you picked the worst possible, and I'm going to explain what I mean by worst, okay? You picked the worst possible wildcard instantiation type. You said, anything goes. And I don't even know what they're going to assign to that variable in the future, okay, like other programmers. So we are back to row types. And the only way the compiler can make the use of a row type safe is by preventing you from adding anything to it. Okay, and now I know that half of you are thinking, so great, now I have a variable and I cannot do anything with it, great. You can do a few things, we're going to go over it, but yes, pretty much the gist of it is you accept, you know, anything into box of unknown, so it's okay to pass parameters as you want, to assign, you know, whatever you want, but you are going to be able to do very little with it that is safe. So a box of unknown is the safe version of a row type. All right? It's kind of like when you talk about computer security. You want to secure your Apache web server, unplug the server from the internet. There, it's secure. All right? So you want maximal security, you get nothing in terms of features. You want some features, okay, so we're going to have to relax the security. The next one is an example of what you can do, which is tremendously exciting. It's we can actually pass a null reference wherever you expect a box of unknown. Okay? So the null is kind of like, well, it's not an object first, right? It's just saying the reference is null. That's why it's going to work. So kind of silly example, but that's actually one of the examples that is used in the literature. If you add a method and you wanted that method in box, for example, box of t, you wanted that method to reset, you know, the reference inside the object or something like that, you could do that. As long as you are, you know, passing null or testing whether the null parameter is equal to your reference or stuff like that, you can do it, no problem. Okay, that's going to be allowed by the compiler because there's no object, there's no type to check, there's no way for you to mess up. Okay, null is always accepted. Next one, well, it's kind of the equivalent of the first one. Okay, box.put xyz. Now we're doing box.contains and a string. It's going to be refused for the same reason. Okay, remember that in this case, what we used to call the type parameter t has been defined as unknown. So this reference variable doesn't want to make any assumption about t. So we reject that one as well. Box to string, no parameter, no problem. Okay, and you get like a string out of it. And then, so those were actually consumer type of type of method. Okay, they were taking a parameter. So now let's look at the methods that are going to return things to you, and let's try to assign what they return, to different data types. So in the first example here, we have a string s. So again, it's not intuitive. Yes, it's a string. We call take. Take is going to return in the class box of t is going to return t as data type. T was string when I created my object. It should work. Well, it's not going to work because of the type of the reference variable. Okay? When you said it's a box of unknown, you really meant it. Okay? What you said is what I'm going to get out of my box when I call take is going to be t. T has been set to unknown. So what you're saying is what I get out of calling box.take is unknown. If it's unknown, here's how the compiler thinks. If it's unknown, how do you want me to check that it's compatible with string? That's it. That's counterintuitive the first time, but that's actually logical. Think about it, okay? And then the last one. Well, the last one works. Kind of like the same reason, no, not really the same reason than for null, okay? Some category of reason maybe, but not really the same reason. In this case, we have no problem because, all right, we agree. What we get out of calling box.take is unknown. It could be anything, any class, any data type, fine. But here's the deal. In Java, every single data type, every single class inherits from object. So if I take a reference out of box.take and I assign that reference to object, yep, that's generic enough. That will work. Okay? So there are a few things you can do. Even for this is the most restrictive wildcard instantiation that we can have. It's unbounded. There are a few things you can do. And sometimes they are going to come in handy. So you need raw data types, but you still want to make sure you use it correctly, use that. Yeah, question?
A question about box.contains. If we cast string to object, will it work?
Oh, if you cast string to object, hold on, let me think about this one a minute. It should work. It should work. It should be a loophole, actually. So the question was, when we do box.contain string ABC, what if we are casting ABC to object? So we make it from a reference to string to a reference to object, and that's the most generic we can be. So even if we are looking at a row type, right, a box, then yeah, we should be able to assign an object. Now, there is a difference between we should be able because internally it's not going to make a difference, and the compiler is going to let us get away with it. You see that, right? Because like in the other example, like for example, if you would have asked me, well, can I do box.put xyz? Personally, that should be allowed because everything matches, right? But because we said our box reference variable is super generic, then the compiler will prevent it. So now your question boils down to, does it lock us down anytime we try to pass a reference just to preserve the integrity of the row type, or is it smart enough to actually see that this is an object reference and therefore it will always find a place in that, in that box?
Yeah, but then we can use casting to object in box.put.
Yeah, and it's the same thing.
And we will remove safety in this case.
Well, first thing, yeah, it's the same thing. If you cast the parameter in box.contain or the parameter in box.put, it's the same thing. Okay, your method is taking a parameter. You just make sure the data type of the parameter is compatible with box of unknown. Okay, so what I was saying is just that it's almost an arbitrary decision. If you want to be paranoid, you lock down every sort of assignment, and I can see why they would do that. Okay, because they don't want you to assign objects. Besides the fact that almost no regular programmer is going to ever manipulate objects, the whole point of generics is to get you away from manipulating reference to object, okay? So I can see why the implementers of the Java compiler would say, no, I'm not going to let you go by with that, okay? At the same time, yes, it's a generic reference, so it should be allowable. Does that make sense? Okay. Does that make sense for everybody, this question? Okay. So that's the worst. That's the worst wildcard that we can, I mean, the worst and the best, okay? It's row type, so if you ever need row types, there you go. But it comes with a lot of restraints. So now we are going to go through two more slides, okay? One for the upper bounded wildcard, and then one for the last type of wildcards that we have, okay? So lower bounded wildcards. So it's the same type of code example, so you should be relatively at home, and it's also going to use the box of T class that we defined initially. So what are we changing? Well, this box local variable now is a box of unknown extends number. So we still don't know what data type we're going to allow, but at least we know something about the family of data types we're going to allow. They all extend number. So that allows us to create an object. Again, when I create an object, I need a concrete data type, okay? So it allows me to create an object of type box of long. I pass a long value. For those of you who've never seen that, the L, uppercase L, is just to say it's a literal integer that is actually a long integer. Okay, so I pass a long value to the constructor, everybody is happy. Now let's deal with the consequences of how we defined the variable box. So the first thing here, the first 4 lines of our example, we try to put a value that is a long in the box. Error. We try to put null, it's okay. Exactly the same as before. We try to test if it contains a long, error. We try to use toString, it's okay. All right. So the logic, the underlying logic here is we have the same behavior, first thing, okay? But the logic of the compiler is we don't know which subclass you mean. That's where, again, it's counterintuitive. When you say, I have a box of unknown extend number, you are thinking like we did with bounded type parameters, so that can be number, that can be integer, that can be double, that can be like, yes, this is what's accepted. But then when you start calling method on that object, the compiler has another question for you. Which one is it? And you said unknown. That's where the compiler gives up. Okay? So even though we know that the data type is going to be box of, unknown extend number, so it's going to, for example, be a box of long, possibly, okay? We are not sure that it's going to be long. It could be long, it could be integer. So at the compilation time, we cannot double check anything more. We cannot guarantee anything more in terms of type safety. That's why the long is not accepted. All right?
But we can cast a number.
Yeah. That does go back to your other question, right? So the remark was, well, yeah, but I can cast to number. Okay, yes, you can cast to number, you can cast to comparable to, you can cast to object. You can cast all the way up, okay? But then that depends on how strict they were in the implementation.
So
Yeah.
we'll put extend string.
Yeah.
Then in that case, we can put the box dot contain that string that we are putting earlier, that ABC. Then you can pass on.
So if I understand your suggestion is here, right here, we've put box of unknown extend string. Okay. So we would have to create here something that is a new box of string, pass a string here, and then what do you want to do with that?
So there, and like box dot put.
Yeah.
We pass that any string like earlier we are passing now. ABC string, any string.
Oh no, yes. If you have a box of unknown extend string, you create a new box of string, and then you pass a string here. You're going to be fine. Second part, the last part, it's kind of the same logic, okay? We use take. So box.take in both cases, we try to assign the resulting reference to a long reference variable L and a number reference variable N. So the number is going to work. Okay, we can get a number actually. So because unknown extends number. However, the only safe assumption we can make is that we can hold a reference of type number. That's the only one we can safely make. It's a non, it extends number, so we know about that, but which one under number possibly, we don't know. But no matter what you return to me that is possibly subclassing number, I can still assign it to a reference of class number, okay? So if it was returning to me, I don't know, an integer, because my reference variable n is number, that works, I can assign, okay? Any subclass of number can be assigned to number, all right? So that's why it works there. So this is where this upper bound is, it comes into play, okay? But we cannot be more specific. So when we return a long, for example, sorry, cannot guarantee that. Last one. And we have been going with a crescendo, and this one has a nice little thing in it that is awful. Lower bounded wildcards. So the last type, the one that uses the keyword super, so the one that we are less familiar with, okay? Most of us have been working with through the upper bounded, you know, with analogies from bounded type parameters, okay? Well, yes, that's extend, okay, I can see where I'm going. Here it's going to be the other way around, reverse, all right? So same example again. What we are doing, this time we're using our box local variable as a box of unknown super long. Okay, so we still don't know the type, but we know it's a super class of long. So what's above long? Number, and then comparable to, then object, all the way up, okay? But we don't know which one, same logic. Then we create a box of number, okay? So we create a box of something that is a super type of long. So yeah, that's okay, we can assign that reference, okay? And we pass a long actually as parameter to our constructor. None of that should be a problem. Then we create a number, name number, which is a new integer 1. Okay, we're going to use it here as parameter. I was wondering why we had this added, but yes, we're going to use it. And then we go through something that is 99% similar to what we have done, except that we have an extra example here and here. So let's look at them in order. So anything that is long, like the constant 1L, uppercase L here, is allowed. Everything that is null, always allowed. But that's not surprising, okay? It was okay everywhere for the reason I already explained. But the long is actually allowed this time. So that's interesting, that's the opposite behavior. When I try to put something here that is a parameter of class integer, okay, but assigned to a variable of reference variable number, this is not going to fly. So again, it's the opposite of what we had before. The logic is the same for. The logic is, since we don't know exactly which superclass you meant by unknown super long, then I cannot guarantee anything. I cannot validate anything, okay? So I can validate things when you talk to me about the bound, long. But when you say unknown super long, then that's it. Now, there is one thing on this slide. I'm going to draw your attention to it, and I'm going to ask you to take it with like not even a grain of salt, a bag of salt, okay? It says here, since we do not know which superclass was meant by unknown super long, we accept parameters of the lower bound, okay? So that's long, or one of its subtypes. You guys are okay with this? Because personally, no, I'm not really okay with that. So I'm double checking that. The only problem is double checking that is not actually as trivial as it sounds. So I will get back to you in an announcement and clarify, you know, whether that second part, the last part of the sentence, or one of its subtypes is actually correct. Otherwise, for like all intent and purpose, like exam and stuff like that, we are going to assume that we accept parameter of the lower bound, because that's guaranteed to work. The last part here, I left it in because it comes actually from Angelica Langer FAQ, okay? And it's a very trustable source. The only thing that I think is I've spotted a few typos here and there, so I think that at some point there were something like 3 or 6 questions that were really similar in structure, and I'm assuming that there has been some cut and paste, you know, so she probably answered one, then cut and pasted, then modified to answer the second question, cut and pasted, modified, and I'm thinking that there is a little bit of snafu here going on because of that. Yeah, you had a question?
Yeah, I have a comment. Like, as I understood, if we use like super long, it means that in the interface of the class, like input method, contains method, it expects us to give it long instances.
If you give long instances with a box of a non-super long, it's going to work. Meaning that it's going to accept it as a argument, and you are going to be able to assign long values.
Yeah,
but you can also pass. Sorry, you can also pass things like box of number. That's the point of unknown super long, right?
Yeah, I mean that in the interface, like compiler will substitute, for example, box.put. IntelliSense will show you it expects long.
Okay.
And that's why you can pass subtypes of long there too. And that's why I think lower bounds are one of its subtypes.
Okay, so the gist of your argument was that when you use, which one was it, IntelliJ?
IntelliSense or
IntelliSense?
some compiler will show you help.
Well, just it suggests to you that you can pass a long. So if you pass a long or a subtype, it should be okay.
Yeah.
So let me like double check that again. I don't want to put something on the slide. If I'm not 100% sure, I'll put like a big warning sign next to it. And as soon as I confirm it, I'll post an announcement or something like that, okay? But yeah, so the idea was, it expects you to pass long values. So if you pass anything that is a subclass of long, it should work. And yeah, your interpretation is sound. So.
Yeah. And I also have like small comment. As I understood, this wildcards is connected to this notion of covariance and countervariance.
Yes.
Invariance.
Yes.
And in Java, I know I read this concept in Scala, and Scala also has like a class nothing that actually is subclass of everything. Like object is a superclass of everything, and the Scala has like class that subclass of everything. It's like provides symmetry in the idea of inheritance. It's just small comment. So.
Well, no, it's a good remark. So the comment was this has to do with invariance, contravariance, and covariance. And yes, if you read about this kind of stuff, you are going to sometimes hear those keywords. I try to avoid them because they were a little bit more theoretical, and I thought maybe that was too theoretical for this course. Okay, but the idea of covariance is when you have like a traditional array of int, right? So not an integer, int, just a primitive data type. You say, for example, my method is going to take an array of int. If you try to pass an array of another data type, then int, sometimes it works, right? It's because arrays are covariance. So the data type array of something is actually covariant. An array of something that is a superclass, like number, is actually covariant with an array of something that is a subclass, like integer. We didn't have that with generics. So generics are not covariant. They are called something invariant, okay? That's the term that's used for them. And all of our problems have stemmed from that. So your remark was, well, in other language, we have different approach to covariance, contravariance, and invariance. Yeah, true. And other language actually tend to do a better job. My understanding about the trade-off is that Java allows us to do things that are more powerful because it uses something called insight covariance, which means that you can specify exactly where you want your covariance. Other language, especially functional language, are going to give you covariance for free, but you cannot really specify when you want it and how you want it. Okay?
Just
go ahead.
In Java to Scala, in Java I see that you can use you cannot use wildcards in the class definition, as you said. But in Scala, actually, you annotate type parameters with how it will be used in covariant way or in contravariant way. So it's kind of embedded in the class definition. But in Java, you use it like in the functional body, like references. So it's a different approach to the same task, but yeah.
And it's not the same result either. Okay, so like there are things you can do in Scala you cannot do necessarily in Java, and vice versa. Okay, so it's more than just aesthetic. It's not the syntax is different, but they both provide you the same feature. No, actually they provide you different features. And if you look at functional language that are even purer than Scala, because Scala still tries to be efficient. Okay, the same way that Clojure tries to be efficient. Clojure is a very good functional programming language, but it makes some trade-off to allow some management of state. because people want that. Okay, programmer wants to still be able to manage state in object at some point. Okay, or at least this generation of programmer does. So it's not only aesthetic differences. When you go from C++ to Java, the worst you have to worry about is probably templates, generics, and the fact that you have real multi inheritance in C++ and something kind of rigged in Java. But that's it. The two languages are still fundamentally, from the same class. When you talk about Java versus Clojure or Scala versus, Haskell, like a purely functional language, or Lisp or Scheme, then you are talking about different categories of language. So then the feature fundamentally change. Forget the syntax. You get used to any syntax, but the features are completely different. Yeah. So I'm taking it you're going to do the case study on Scala, right?
No.
Not just joking. But okay, last examples here, box.take. So we are trying to get something out of the take method. And because of the way we define the box variable, we know we get a none, which is super of long. Okay, but we don't know which one. So if you don't know which superclass you're going to get, the only safe assumption is object. The super class that is completely at the top of everything. Okay, so that's why if you try to assign this to a reference variable L of type long, nope, can do. If you try to assign it to number, superclass of long, nope, cannot do. If you try to assign it to object, yeah, everything is an object. Okay, so we go again to the least permissive aspect. All right. So this is the last version of the table that has been growing and growing and growing. I'm going to go over it rather quickly, but this is really just a summary of what we covered. I just tried to phrase it differently, probably use the different source actually than Angelica Langler FAQ, just so that you have like different statement about the same thing. Again, everybody learns differently, but one of the things that I used to do a lot in my graduate course work was actually trying to find different books on the same topic, different lecture. I mean, it was less easy to find lectures online back then by far, but the idea was to have like two different people explain to me the same thing. And most of the time, at the beginning, you cannot reconciliate the explanation. Only when you can reconciliate them, then you have gained a better understanding of the topic you're studying. Okay? It's kind of trying to confuse yourself by taking different perspective until the confusion is clearly identified. Then you ask question, you overcome your confusion, and then you have solid understanding. Okay? So let's look at what we have. So I removed some of the rows there that were on row types and concrete instantiation of a generic type. So what we are left with is upper, lower, and unbounded. So let's start with unbounded. That's always the simplest to understand, I guess. So when you are talking about getters, that's similar to what we just saw. Okay, you can only assign what you get out of such an object to object references, just because we do not know actually what the question mark unknown stands for. The counterpart of that is when you try to call a setter, you cannot set anything there. You cannot set anything because not even object actually. So actually that might answer your question from sooner. I need to track down where I got that not even with an object, a reference here, but that would confirm actually that the implementation in the JVM, in the Java compiler is strict and doesn't even allow to do those kind of typecasting, that you suggested. Passing null is allowed because it doesn't do anything. That's fine. Next one, let's take a look at the next most intuitive one, which is the upper bounded generally. So list of unknown extend employee. So when you are trying to call getters, you are able to call method that return object of the unknown type and assign them to ref variable of type. For example, here we have unknown extend employee, so you can assign to a variable of type employee. Since the unknown type will be a subtype of employee by definition, that's allowed. No problem there. For the setter, you are unable to call method that take argument of the unknown type. Yeah, the logic is the same than here, okay? You don't know exactly which one is going to be, so you have to go with a bound. In this case, the bound is object, lower left, okay? In this case, we cannot tell, so we're not going to let it go. And then the middle one, the lower bounded, So unable to call method that return object of the unknown type. That makes sense. Okay, that's kind of the same thing that we already talked about. But you are able actually to return the value of any superclass of employee. The only safe thing to do is to assign it to object reference variable. I hate when the slides have a lot of text because I get trapped into reading the text instead of actually lecturing. So sorry about that. I made the slide a little bit too verbose, but hopefully it's okay because it's just a summary of what we already covered. And then the last case is lower bounded and set. So you are trying to pass one of those list of unknown super employee to actually a method. So you're able to call the method through a lower bounded wildcard parameter type, the take argument of the unknown type. We know it will be a superclass of employee, so we may expect object. Okay, so this is just based on superclass employee, subclass employee, and just unknown. Okay, so it's different from the example that we went through in the previous slide, but you can use it with any type, so that's okay. It's the same rule. Okay, so that's the messiest part of generics. So bottom line with this, when do you use that kind of stuff? Be careful about using that kind of stuff, obviously, because it gets messy really fast. The golden rule is, at least for you, every time you want badly a raw data type, consider wildcards. Okay? The worst that can happen is, like, for example, I had some legacy code, which I already mentioned in a previous lecture, and that legacy code was written pre-generics. And I had a bunch of unchecked warnings in my code when I tried to compile it with, a more recent version of the Java compiler. One of the ways you can overcome those is by going with unbounded wildcards. And it's going to work, I would say, most of the time if you were not doing anything silly with your raw types. Now, if you were actually adding to some of your parameter data based on their raw type or extracting data, then you need to use upper bounded or lower bounded wildcard data types. Under no circumstances, you should find yourself going past 2 levels of nesting in your parameterized data type. Okay, so something like T extends and then angular brackets again, unknown extends number, for example. That would be absolutely the most complicated you should ever encounter. If you start writing a method that is actually more complicated than that, take a break. Think about exactly what your data type is going to accept, because it's possible that you're just back to a raw type. Okay, you wrote a very complex generic expression, but when you try to find actually the data type that are allowed, it turns out that nothing is allowed. Your constraints contradict themselves, so you're better off going with actually unbounded. All right. Okay. This is I'm going to finish today's session with this 2 recommendations. This, which I think we have some in our library if you are curious. It's an old book, but actually very good about Java. It's one of those books that is not there to teach you how to program, so it's not going to tell you, this is a for loop, etc. Now, it's a book that is focused on everything that can go wrong and explaining why it goes wrong, kind of like what we try to do with those lectures. Okay, I always try to take counter examples and stuff like that. This is another very good reference if you really want to understand Java programming, actually. There is also a similar book for JavaScript. JavaScript, the good parts, I think is the name. Same thing, very small books. Okay, not verbose, but really hit right on the nail the difficulty of the language. And then this is based actually on that book. So even if you're not going to take a look at the book, which is fine, it's not mandatory reading for this class. Again, another optional thing you might want to take a look at, watch this presentation from Joshua Block. And is more specifically, at 22 minutes, you're going to have an item. He goes through a few items from his book. Okay, item 28 is going to be really relevant to wildcards. Item 29 at 36 minutes, that's really just if you want to mess around and give yourself a brain cramp, okay? But it's really interesting. So I really recommend that you take a look at least at, between minute 22 and minute 36, because that's relevant to wildcards. And he actually introduces the same thing, but use this analogy of producers, extend, consumer, super. Okay, this is an acronym PEX that is there to remind you, when you can put things into a parameter, take things out of that parameter depending on the wildcard that you're using. So at least does 14 minutes of video, definitely worth a lesson, okay, to supplement this lecture. All right, and we are done with generics. There are a few more slides in the slide deck, but these are just review of you can do this, you cannot do that. I'm going to leave them in the slide deck, but I'm not going to cover them in lecture. The next session, we are going to jump directly into collection. Collections is going to be a lot easier than especially this last material on wildcards. So it's going to get you a little review of how to use collection, and we are going to try to connect it to what we have learned about generics, okay? Because generics are used everywhere in the Java collection framework. All right, I'm going to stop the recording, start uploading, and if you have any question, I'll be here.
Professor.
Yep, hold on just one.